Hi all, today in this video we can study about the last portion of module 5, that is forward error correction mechanism and Hamming distance. We had already discussed about what are the types of errors. Uh, there are two types of errors, single bit error and burst error. So how to detect these errors and how to correct it. We had already discussed about the detection process, error detection process, like parity check and its subtypes, cyclic redundancy check. Okay, so now you can see how to the error is corrected at the receiver side by using a forward error correction mechanism, that is Hamming distance. You can control the error. So forward error correction, it's a method of obtaining error control in data transmission. Here the source, the transmitter and the receiver is there, and the center will transmit some redundant data to the destination. So at the receiver, it recognizes only the portion of data that contains no apparent errors. So that is actually forward error correction mechanism. We have forward error correction codes like Hamming codes, binary convolution codes, Reed-Solomon codes, low density parity check. All are used for correcting the error or controlling the error in the data communication system. So in which you are studying what is Hamming distance. So Hamming distance means it's comparing between two data words. So Hamming distance is the number of differences between the corresponding bits. If we have two words or two data words x and y, and how to find out the Hamming distance? So it can be represented as d of x comma y. So actually the Hamming distance is the number of differences between these two data words, or how many numbers of bits are differed in x and y. That is actually calculated by using this Hamming distance. So it can be represented as d of x comma y. X and y are two code words or data words. So let us find the Hamming distance between two pairs of words. We have two words like 000 and 011. So how to find out the Hamming distance? So d of 000 comma 1011. So you can see from these two data words, two bits are altered. Okay, first bit is same for first data word and second data word, but the second and third word, you can see in first word it is 00, but in the second word it is 11. So the number of bits altered is 2. So the Hamming distance between these two words are 2. Okay, so or else you can find out by using XOR operation. You can XOR this, and two ones are uh, getting at the result. And the Hamming distance in the next example, you can see the Hamming distance of 10101 and 11110 is 3. How the number of bits altered between these two words are 3. So the Hamming distance is 3. In next figure, you can see its explanation, how many words bits are altered in these two uh, example. And what is the minimum Hamming distance? Minimum Hamming distance is the smallest Hamming distance between all possible pairs in a set of words. You have given a set of words, you have to find out the Hamming distance between each pair. Okay, then find out which one is the minimum distance. That is the minimum Hamming distance. You can see in an example. So you have 4 data words: 00000 first word, 01011 second word, 10101 third word, and 11110 is the fourth word. First, you have to find out the distance between, or the Hamming distance between each pair. So first you check first word and second word. Then you check first word and third word. Then you check first word and fourth word. Okay. So you get 3, 3 and 4. Next, you check second and third word, second and fourth word. Finally, you get 4 and 3. Last, you check third word and fourth word to find out the Hamming distance. So you got 3 as the result. So in which one is the minimum distance? That is D is equal to 3. That is the minimum Hamming distance for these pairs. Okay. So by using this minimum Hamming distance, how can you detect how many bits are errored? Or if the minimum Hamming distance is D, you can detect D minus 1 errors in the given set of words. Okay, so if the D is equal to 3, that means the minimum Hamming distance is equal to 3, then you can find out 2 errors from the given set of pairs. And how many errors can be fixed by using this D? If you have a minimum distance of D, and you can fix D minus 1 by 2 errors. Okay, it's a least floor. That symbol is used for least floor. You can fix at least floor 3 minus 1 by 2. That is equal to 3 minus 1 is 2. 2 by 2 is 1. 1 error. If it is equal to the result is 1.5, then you can it is a least floor mechanism, so you can correct one error. Okay, if it is 1 point something. Okay, so it is changed to least floor. So if the minimum Hamming distance is D, then you can find out D minus 1 error, or you can detect D minus 1 error. If the minimum Hamming distance is D, and you can fix D minus 1 by 2 least floor errors. Okay, so by using the forward error correction mechanism, you can detect and correct the error. So for the simplest mechanism in a forward error correction mechanism is Hamming distance. Okay, thank you.